Hello, my friends. This is just going to be a fabulous day for me because I am going to brag all about me because I decided that I would look back on my history, 72 years old now, and now they have finally figured out that the things that I had talked about right here in my research, and I will show you, and I can carbon date this paper. It's so old, it's from like 1970. And I was working on dipole molecular moments back then, and now they have finally decided, yes, these things that I talked about are exactly correct. They haven't really come to that finalization, but they're so damn close. And I show them the stuff, and they still won't respond. It's just very upsetting. This has been 50 years. So I am just going to keep blowing my horn until my horn explodes. So let's start blowing this puppy. You see this? This event was predicted 1973. They'd never seen it in the real world. Well, no, I didn't either. I knew that the nucleus could not be what they said. It was totally impossible. Now, where did I get down here? Well, let's just get down here to the bottom line. I always like to go to the bottom. It says the gluons and multi-gluon exchanges happen for the briefest of moments at the most extreme energies. These are when protons hit head-on, or particles hit head-on. They exchange these little tiny particles, which are muons, electrons. That's all that exists. And now they finally decide they're going to sort of talk about it in a roundabout way. And listen to how you've always heard there's protons, there's neutrons, and then there's tiny little things that are called electrons. Well, that is totally wrong. Protons and neutrons are made of electrons in stable quantities. And now they finally decide, well, that's probably right, after 50 years of denying it. So now they're talking about gluons, double gluons, glue balls. They're so screwed up. They're so lost. They're just trying to cover their own bases, and it's just nonsense now. It's going to be hilarious very soon. The detection of the odoron won't change the face of physics. Oh, yes, it will, my friends. It says back when researchers first spotted possible evidence for these particles, this is 50 years ago, many other researchers argue it's not a true particle at all, but a quasi-particle. And it is. It's not a particle that exists on its own. It's a particle that briefly exists. Well, the electrons and all of these things exist, but they exist in a very complex order that makes them molecules. So, because it says it's nothing more than a temporary arrangement of smaller particles. And that's all everything is. If you smash anything, it will turn into other particles because they're being broken down. It's nuclear decay. It's molecular rearrangement. It's nothing more than a temporary arrangement of tiny little particles called electrons. And it's now, listen to this, now they're covering themselves. Oh, the same thing could be said of protons and neutrons. However, they used to say before they're just one big gigantic thing. No, they are tiny little arrangements of smaller particles called electrons. They're finally fessing up. It says Royan said the discovery is important because it confirms the basic ideas about particle physics researchers used to predict the odoron's existence in 1973 were correct. Well, guess what? I predicted them. Well, not exactly that, but I predicted there was no question whatsoever that the nucleus of all atoms had to consist of dipoles, which Coulombic forces. That's all that exists. I believe it's as evident that Coulombic forces are the nature of atomic and molecular behavior. The subatomic particles and all particles are Coulombic. Now, I'm just going to run about my story here because I did this in 1970. I got out of the Army in 1970, and I went right into all kinds of things. And I started out with physics and quantum and chemistry and all that. But before I went in the Army, my father had gotten me a job with General Electric, working on the biggest equipment in the world. And no kid would ever get that job. I was like 18 years old. And but he got me in on it because he ran Wallingford Steel Company, which was making super metals and all kinds of stuff, and he knew all about the atomic interactions between molecules and how you slough off slag and, you know, rolling mills. The guy was just absolutely brilliant. His name was Eugene. I used to call him Eugenius. Now, so I'm digging into this stuff myself, and I'm loving it as deep as you can get into it. So I get out of the Army, I get into all of this stuff, and they shut me down. This my professor wanted. I said, I'm getting an A. I know more than you do about it, and I did. I got my A because I destroyed him. He said, no, I'm not giving you an A because you came up with the wrong conclusion. I said, the wrong conclusion? I said, you got the wrong conclusion. I got the right conclusion. I said, let's figure out something. I said, and I did. I challenged him to come up with the centers of positive and negativity, and I think it was PCl3, something like that. It was a polar molecule, and it came out to be 0.45 debis. As I recall, I can recall these little details, but I can't recall where I lived. Anyway, it was here somewhere. Anyway, whatever. My point being is, he knew at the end I knew more than he did, but I decided, no, they were wrong, I was right. There was no positive center and little tiny electrons. It just doesn't work. They come in like that. It's insanity. It was insanity. I absolutely went insane when he said that, no, you have to agree with that. And I said, no, I don't have to agree with that. Anyway, that's water over it there. H2O, actually. Okay, my friends, Roger Spur, Mudfossil University, once again challenging academia and all of the others. Okay, mes amis, this is Roger from Mudfossil University, starting a new channel. It's going to be called Roger's Research Rambles. And I'm just going to ramble on about all my different areas of research. And I was forced into all of these different zones by the rejection and dismissal of the educational system. So I am just going to ramble on about the things I've been doing for 50 years, and they just now announced that the things that I talked about 50 years ago were correct. And now they just discovered it. Muons, biggest thing in history now. And electron showers. They have no clue where they came from. They just know they're particles. I know where they came from. They were attached together. Let's ramble. Okay, my friends, they're all looking for the muon. That's it right there, the black part, the little black ball. You see it? And this is light right here, flowing as a wave, which is the magnetic region that controls the particle, which I just showed you is way back here. However, the magnetism that it controls, which concusses with all the other magnetic particles, and every single thing there is magnetic, so in the gases and air and so forth, so they concuss and glow a little bit, but the most in glow is here. Now, we accelerated it through a venturi and made the particle pull itself right out of the wave, so obviously light can accelerate. You know, they talk about a vacuum, this and that. The only thing a vacuum is to slow it down from particles being in front of it. We accelerate it, so who cares? It's totally wrong about everything. Now, in this concussion, the reverse EMF, electromotive force, forces these particles to show up where you would never even see these. But they're pushing back against them so hard that now they become obvious. And this zone of influence is just a gigantic, concussive, explosive, dynamic force that feeds itself all the way back to there. It's absolutely phenomenal. Now, the particle was here, and when it crashed through the venturi, it separated. The black goes all the way out of the picture and reassociates here. And this is light, so, and this is like extremely, you know, enlarged. So this is just, it comes right back together. But these black balls, which are the muons, I show you them, they exist outside of just attached. They can completely separate. I show you this right this instant. In that venturi, bada bing. The four of them work together like this. Hold on, let me put a little light on the subject. When they came in, they were here. Then they just completely disassociated from each other. Totally, completely. The black did nothing. No absorption, no emission, no concussion. Just get the hell out of the way. Don't go through here. Stay away from us. We are exploders. You are attractors. And then when it got out of here, nothing but energy here, and hundreds of times minimum more than it had when it came in. So that's an increase in energy, and we did nothing whatsoever other than have a venturi, which is nothing more than 2 round pins, and it forced that to explode its magnetic regions. That's raw energy. That is free energy. Somebody's going to have to convince me I'm wrong. I'm right. As far as I'm concerned, until you can show me I'm wrong, I am the one that's right. All right, like I said, these are rambles, so I'm going to get into that kind of attitude like, why aren't you people listening to me? I showed you this evidence 5-6 years ago. Not a single word about it until just, maybe 2 years ago they started saying, well, we really got problems. And then a year ago they said, yeah, nothing's right. And then just a couple of days ago they said, yeah, totally 100% wrong. We got to start all over. Well, again, that's water over the dam. Let's just move forward. This is a ramble. I'm not going to just dismiss anything. I'm just going to let it flow. If I start to get in an ugly mood, well, an ugly mood you will have to live through. I'm not going to do that. I'm going to try hard. And I will dismiss some of my comments. I'll cut them out of here because sometimes I do get really ugly. I mean, ugly. If you'd have gone through the things I've gone through, you'd be pretty ugly too. This one I'm going to keep in. Have a nice day. So don't forget now, these are the black balls. These are the white showers I just showed you. And then we had a guy, Rod Warren, did the light acceleration pictures and so forth. And then we sent these pictures to Fabian Boulay, who has some kind of special enhancement stuff. And this is what it shows up. This was more brilliant than that one. I wouldn't have seen that really. But now that I look at it, I can tell. And however he did it. And the same thing with the black. The black, you see the black is surrounded like it's just a void here. Here it's not exactly the same. Again, a lot to look at, but I can see this is actually an interaction with other particles. This is a bouncer off of these particles. And that's exactly what they're talking about. Oh, they wobble, they spin. Yes. This is like a balloon hitting another balloon. Well, one of them's got to go one way or the other. So they wobble, yes, absolutely. It's exactly what they're talking about, which is only a few days ago. They've admitted it because they finished their Muon G2 experiment. And it shows, yes, all the things I've been saying are correct. All the things Brookhaven were saying are correct. And the nucleus, it can't possibly be what Bohr said it was. And I have been saying this since 1970. All right, now I showed you the light, just red laser, pulse laser, and that's normal. Now, this is the accelerated. This is the zone of concussion. Coming out of here this way at us is the Higgs fields, which are, I believe, at this point, they're reassociating. But between here and here, they are raw energy at these little spits. And then there's a particle nobody's ever seen. I'll show you that in a second. But here's what I want you to see. And again, Fabian Boulay did this with some kind of enhanced software. I don't know what he used. But this is what's coming out of the Venturi. Now, at some point, they start to re-establish themselves as Higgs fields of light spinning particles. And I believe at this point, they've reattached to that muon dark matter. But I can't be positive. But I'm almost certain because somehow he enhanced this to look like this, which is exactly what I would expect it to look like. The more I keep looking at it, I see this as a ball. Originally, I just saw it as a spinning little, completely spinning little wiry looking thing, which would be a right-hand spin coming at us, which is correct. We're coming this way. However, now I kept looking at it, and I keep seeing these. These are the most impactful. The darker it is in the center means the harder the outside white part is pushing against other white parts, which is everything has white in it, which is in the atmosphere. So they're coming through, smashing in. Let me put a light over here so you can see a little better. All right, so here they are. coming at us. And we saw them over in the Higgs fields. And these are the protruding portions. These are the most forward portions, and they're impacting hardest. Now, what's going on in here is, I believe, is a crushing effect of fields interacting with other fields, causing these particles that are in the between the fields to be compressed. They're not forward of these, they're just more compressed. Now, if you look at this carefully, you'll see that it almost makes a round circle around this. Like, you see this six-pack here? You see this six-pack here? You see that six-pack here? You see that six-pack here? You see the six-pack? Six-pack here, six-pack here. All of them around, and it almost like it wraps right around like a buckyball looking thing. But it is the photon, and the photon is a ball of light. So I believe this is literally a ball. And all we're seeing is the leading tip of the ball. And over here, you can see the leading tip of the ball right here. Now, I'm going to show you a different picture of it. It'll look better. Hold on. All right, this one just gives you a little bit more. These are the leading tips. And then in between, I believe there's a little extra compression causing these little pinches in between to glow. Anytime they're pinched, they glow. That's the nature of pinch, push to shove. Push to shove means glow. And then the dark matter ends up going into the center, and everything else surrounds it, like to protect it almost. Because nothing else can invade at that point. It bounces. All right, like I said, this is just a ramble, so I'm going to go through it again. This is the light literally being sucked through the Venturian, because this is the center of it. However, these are other fields of light coming this way, just like this one is. You see them, but you don't see them here. The reason is they're not accelerated. You wouldn't see them, you'd just see sort of a glow, what is exactly what you did see. Well, what's happening? Why are we seeing these reverse waves? I think I talked about this before, but I might not have. That is what's called reverse electromotive force. Electromotive, electromotion, force, electrons in motion forcing against something. This is a reverse electron in motion forcing back, causing the concussion in reverse against the particles that are coming, so they glow, just like they're doing here. Only here it's being accelerated through the Venturi. These are what they call interference patterns. And if you look up any physics book, it's going to say they're flapping like waves of water because there's two slits. This is only a single slit. And the reason they're separated like this is because each one of these white particles does not want to be next to each other. So they push to shove, push to shove, push to shove, push to shove, line, 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 line. Case closed. Here they start to re-establish themselves as actually photons again. And they talk about colorized light, green, red, blue. Well, absolutely, no question. You saw the red particles. Let's take another look again. Now, if you look up something called a 21 centimeter line, it talks about parallel polarities. These are nothing more than a polarity. The red and the white and the black in this laying flat parallel looking situation is what they see normally. And then they twist and so forth when you bring in other magnetism within a 21 centimeter line of hydrogen. That's just gets very deep, so don't worry about it. The point being is, as they are being crushed, however, just before they explode in this Venturi, this is pulse, 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 and then ba-boom, because they have to do something. Their magnetic field is not right here. It's like this big. It's like this big. I'm not kidding you. It's 8 centimeters for a hydrogen. Now these are light, so they're not going to be like 8 centimeters. These hydrogen is 1,800 times bigger than these, so this might be, well, divide, I don't know. It's going to be smaller, but it's still going to be a big magnetic region. And we could see them as the disks. Well, we saw the magnetic region. See, this is that's why I'm going to just babble on. That's the way I'm going to do this from now on. Now, and then you talk about color. There's the color. Rod did this with blue going through glass to see what the glass effect would be on the laser, and you can see it. It's sort of subduing it, and it's sort of creating an open, it's pushing all the particles away to the sides and creating a shock wave, just like a jet fighter, just like identical to a jet fighter. Did I show you the blue? No, I guess I didn't. See the blue here? The blue we don't see. Well, I haven't seen it. I don't know whether Rod's ever seen it or not. But you don't see it specifically as a particle, but you can see that it is spinning to the right. That means it would be drifting to the left as the snapshot is taken, which it is. And we can see that it's slowing down or concussing or whatever it's doing here, but it's certainly not the same width as it was starting down there as it is here. And these are other trails of light that have not impacted so strongly yet, apparently. Again, we need to look at this stuff. I don't know. I don't have all the answers for this, but I can tell you what, it's very, very intriguing. Look at that. Look at that. See? You see that? And they talk about light colorization. Now, where's the green one? All right. This is the green in the trail. You see the green, and it's much more powerful than the red. And the blue, I believe, is much more powerful than that. Well, I know it is. And here it is. It's coming spinning, and then all of a sudden you see it here. Now, I don't know if it's coming this way or if it's going that way, to be perfectly honest with you. Because it will compress, and when it compresses, it will display, and then it will disassociate. Now, that could be where it's happening here, because this is much more energetic than here. I don't know. This, again, I didn't do these actual experiments. I did some of them, but Rod was so good, I just stayed out of it. Here's the particle, and he was showing me these things, and he still is. You see, I keep getting stuff from him regularly. He's just absolutely amazing, and nobody pays attention to anything he does. Nobody's paying attention to anything I do either. But this is right now, the muon is, which is this, is in the news, so it's time to start paying attention. This is a wobbling top. As this comes through, if it's going to hit here, some of them, the white is down here. As that spins, the white will be here. So it'll spin, and then that white will be on the back side, and this white will come forward. And as that back goes to the back side, this white comes forward, and I believe it spins in a right-hand spin. That's it's called the right-hand rule. Now, when you get into the high speed, let's see, we got Fabian green and red. Now we got an understanding of what the power of light is. What's the power of the red? That's it. That's it. Done. Case closed. It impacted after the Venturi. You can see it coming through the Venturi. It's nowhere near as powerful as the green. And it's, at that point, it's over. Although there is a taste of red here, which I think is being pushed by the green. I don't know. No, that's the red still. Okay. Wow. This is how I do these things. This is the first time I saw that. That red reconcussed out here. The green reconcussed way out here. So there may be some, like, distance that we could measure between where the green stops and reconcusses and the red stops, but it is a much less powerful particle. And you can see how this green has forced the red to deviate off of its laser path and forced all the particles that were red to push down, and then green takes over. You see it? Now, these are the particles in green. So we know well, I showed you the particles in green. They look absolutely fabulous. And this was Fabian doing the same thing, only without having the red affecting it. And here is the impact zone, way out here. I find this interesting, though, that it did the same jobber going off this way that it did with the red. So, that gives me a little bit You know, like again, you just have to think about it. These people are just doing this as a labor of love. They're not sitting this all day collecting a paycheck to do this, and I'm not either. I wouldn't accept a paycheck. I don't want any money. I just want to do it to see what the hell's going on. But you can see he's got them all over the place too. He knows the same thing, see? And we've got this in so many variations and so many ways. There's Fabian got some more. See, these are Higgs fields being impacted by other Higgs fields. Let me show you we can see them back here. They're all over the place. Which they're just nothing more than light particles. Here's my friend Renz did this with his finger. Well, these are the particles coming out of the sun in certain molecular days. Where's Renz here? Well, it's light bouncing off and interacting with other molecules that have different bounce factors. Let's just go with that. They used to call it string theory. I call it spring theory. Some of them, and here's why. Here's why. This is the particle. Some of them are long like this. It's red. It's spinning. And I could show you its spin. I can show you it actually spin. Where is it? Light spinning. There it is right there. This is coming this way. This is going over that side through the slit. And this is coming over this side through the slit. So we see them separate. And the reason we're seeing them in zones is because they don't want to be next to each other, as I told you before. They will push you and push me, and we will create a strip, and a strip, and a strip, and a strip. And some of them will come this way, and some of them will come further out, and there'll be less hit here. But most of them will end up going through the center. That's why you get this big impact. So all it is spinning light. Now, what did I talk about before? I talked about some really crazy things. This one right here. Yikes. Run for your life. I don't know what it is. I have no idea. But I can tell you what. This was the particle that created this particle. It's interacting with this field. Now, did it just create that field? I believe it did. There was no field here. There was no field here. This is what the fields look like. They're not just nothing. And this was nothing until it became something. And part of it became something here, and I can see it almost like trailing off, and part of it just discharged and rolled around this one. Now, again, a lot to look at. Now, this is that particle, I believe. And again, it's got to be, somebody's got to look a little deeper. All right, here it is right here. Remember, it's coming out of the slit towards us. We saw there was a zone of complete whiteness. That's it, until they start to interact as fields. Well, this one here, I believe, is spinning in reverse. What would that mean? That would, in my mind, mean that instead of pushing the particles away in a spinning outward manner to create these fields, it would spin them and collect them, bring them into them itself, and make itself white again in an extremely powerful position. Now, the other thing I see here is this one being pinched by these two fields. Now, the effect of it is to elongate one of these Higgs fields and crush it. And not only crush it, squirt it out and turn its color from red to blue. Now that is, there's things here that I never, ever, ever would have expected. And this one here I would have never expected, is that when these were attached together as particles, that they could literally separate the positive and negative. That is the positive source and the negative source, which they are dipoles. And the black ones have nothing more than an attractive portion. That's all. That's all they do. No concussion, no explosion, no emitting, no absorption, no nothing. It can't be seen. The only way we could ever see them is because of this. Because of this. You'd never see those black particles. And that's why they never knew they were there. That is dark matter. That's a muon. That is the particle they're talking about now. This huge, big hullabaloo about it. Physics is all changed now. Absolutely it's changed. Electron flood theory is the only thing that works, which means that every single thing there is made out of electrons. And electrons are nothing but more like this. They're one of those. That will burn into you, that will fuse into something, that will incorporate and make particles, that will make matter. This is different. This is light. This will bang and bounce and create energy. This will create heat. This will create light. This will create warmth, and it will leave places to become colder. Well, these leave places to the electrons too. But what I'm getting at is there's sort of two ways of thinking about it. Half of this is going to burn you. Together, it's neutral. It doesn't want to burn you. It doesn't want to burn you. It wants to bounce off you. All right? There's, again, a lot to think about. And I'm telling you right now, that is raw, free energy. I don't see, nobody can convince me that that's not true. And all you would have to do is have a harvest plate here prior to it fusing back to the dark matter. You would have to have something right there that would absorb this 200 times, 500 times, 1,000 times. I don't know what it is, but much more than was coming in. It would absorb it and force it to go through some kind of a device or collection area, and whatever's left over would come out and attach to these particles here. You could send these into a carbon dioxide, I believe. If you sent this into carbon dioxide, I believe these particles would force possibly the oxygens in the carbon dioxide to end up being hydrocarbons. All right, and why do I say that? Well, where did hydrogen come from? Well, oxygen is nothing more than a bunch of these tiny little particles too. If you could break them all up and then refuse them back together as hydrogen instead of oxygen, then you could just reburn it. That's all. And how would you fuse them back together in the right configuration? You'd use vibration. Let me show you. Okay, once again, this is Brush Pup. I've shown this a million times. He's got 2.8 million subscribers, 17 million hits. Half of those are mine. Now, if you want to find the secrets of the universe thinking in terms of energy, stop there. Then say what you have to consider is frequency and vibration. It's not think in terms of energy, frequency. Energy is frequency and vibration. That's all that exists. Somebody took that out of context. Now listen. I'm going to explain exactly what's going on. They are going to be using salt. Now salt is a polar molecule, and it's on both sides of the periodic chart. NaCl. No extra electrons, a ton of extra electrons. Now they're going to put it on top of this table. You see it's salt? Now let me just explain what's happening here. And I'm going to actually turn this down so that I can comment as we go along. Now, what they're doing, let me open this up, is they have a plate here. And that plate is nothing more than a pile of electrons on the surface of that plate. Everything there is coated with electrons. Electrons are the outer surface of every single thing there is. So, the electrons are on the surface of this metal plate. They are taking, these wires have a frequency generator in there. It's actually vibrating the plate, literally vibrating, just like going bzzz, like a string on a guitar. Only they're inducing a vibration into it. Well, what does that do? The NaCl, there's the polar molecule is being forced to push away as that vibration pushes it back and forth. So it ends up pushing it, and you see they're all like just crazy like this. However, you're going to hit a certain number of them and a certain frequency. They're going to be showing a frequency, and bam, it'll lock in. Now, for those of you that are not familiar with atomic structure, it starts out with very few electrons, and you have hydrogen. But hydrogen has about 1850 or so electrons make a hydrogen. They say it's one proton and one electron. That's crazy. It's 1850. Helium ends up being 7,352, I believe. And by the time you get up into these bigger numbers here, you're up into zillions. Now, and that gives you so much ability for these molecules to lock into other molecules. And you see this happen. These are going to be the actual atoms, the structure of these actual atoms. I'm telling you, I'm going to show you hydrogen, which has only the ability to influence a couple of electrons. The same thing with helium. So the first frequency will be this row. Then there'll be the next one that goes into what they call the rule of 8, which means that you want to have 8 electrons, and then it stays 8 all the way down, although it gets extremely complex, but you still see the rule of 8 show up. I know this is getting rambly, but that's what I am going to do, is a ramble. So here's the salt, here's the vibration. Tesla said watch, and so do I. Now, they're going to go, okay, now they're going to vibrate the metal plate. You see the pitch, it says, as the pitch of the tone increases, geometric patterns are formed. And the pitch is nothing more than pushing back and forth. At first it goes, and the higher it goes in the bouncing back and forth, the more complex the patterns get. And they only lock in at an exact frequency. That's the beauty of this. And that frequency is what's called a resonance frequency. And there is some form of a resonance shaking of the whole universe. And I think it's like 4.82 hertz, something like that. Don't quote me on any of that. And I don't even know if it's true. But I believe there has to be something that affects these molecules to form into these patterns. So something's shaking the universe, just like they're shaking this tone generator. See, these are hertz. Hertz are a cycle, one cycle of a wave. You see that? That right there is the first line of the periodic chart, which is just a very, very small core and just an ability to have 1, 2, 3, or 4 electrons, basically tops. They say 2 is tops. I don't know. Let's keep going. But that's at a very low frequency. But it locks in. Otherwise, they're just, now they're going to put a whole batch more in. Now you're going to see the rule of 8. You watch around here. You see it? So now you have the core area, and they push out the electrons into zones called the rule of 8. Just 1, 2, 3, 4, 5, 6, 7, 8. It's just as simple as that. And you keep seeing this. Now that's the lowest level, so now we were down in this level. Then it's going to get more complex, and more complex as we go down the lines of the periodic chart. But you'll still see, if you look real careful, you can start making out these rules of 8. And they're very, and they just keep going up in hertz. You see it? There's a rule of 8 again, right around the center. But now you're influencing other electrons in the outer fields. So now everybody's pushing and shoving. And what I want you to take into account here is all of these zones of dark matter. And that's really what they are. These are, the particles are forcing themselves away magnetically and creating these zones of dark matter. I can't account for it, but I can tell you what, it just keeps getting more and more complex as you get higher and higher up. And that is exactly what happens here. Until you get to a certain point in the periodic chart where you can't keep them in that snowball anymore. See, here's the rule of 8 again, but it's changed to some other strange looking form. And you come way out, there's no sense in looking at every one of these, but look way out here, look. It just keeps getting more and more complex. And that is exactly what happens here until you hit a certain point where the frequency that exists in the universe cannot stay together, all of these particles at the same time. Now, there is a point I want to make here. Hold on. All right, the point I want to make here is, let's just say all of these particles are those light particles that I showed you, which were separated into little bits and pieces. Now, they have to come back together. As they were coming back together now, they're coming back into photons. And in the correct frequency, if they were passing through with the correct frequency, we may be able to push them back into hydrocarbons instead of carbon dioxide. Once they pass through this chaos, we may be able to reconstitute them back into their combustible form. And if we could do that, you'd just keep driving all day long with the same thing. It would burn it, it would bring it through here, it would reconfigure it into hydrocarbons again, it would burn it, it would turn it back literally into water. You know, hydrocarbons, that's what happens. They condense into water in the tailpipes of cars and so forth. I don't know if they do that anymore, but they used to, and that would rot the tailpipes out. And the mufflers, you'd have to buy a new muffler every couple of years because of the water condensation. My father ran his car on water and kerosene during World War II. Couldn't get gasoline. And I think you could run it on water. As I keep looking into this, I believe you can do it on water. And I believe he told me, now this goes back 50-something years, he told me all about this, but he didn't really elaborate enough. But I believe what he told me was they couldn't run it specifically only on water because it cracked the pistons. And he thought it had something to do with the water being, I don't know what he was thinking. I didn't pay that much attention, to be perfectly honest with you. But I know he did say, he said what we had to do was put another Venturi in there and add the water into kerosene or something along that line. And it ran. And he said it ran pretty good. But he couldn't get gasoline, that's why. So, you know, there's a lot of things we have to take into account. And I don't think it's impossible to just continuously use the hydrocarbons over and over and over. Because they're going to turn into carbon dioxide, and then they're going to turn back into hydrocarbons again if this would work.